Hello, Damian. This is a kind of a review of how you can sense concentration gradients when you're using your ANT algorithms in StarLogo TNG. First of all, here's a site here at MIT that I can send you the URL for in the email. But it talks about how concentrations are formed and how you might have your agents walking around and moving up gradient. In this case, the agents move, and as they don't detect a gradient where they see a decreasing frequency of a particular particle, then they move more randomly. And when they have a greater frequency, they move less randomly. So it's called a bias random walk. And bacteria do that as well as ants. For finding food or avoiding poisons. And there's ideas of maybe how that's implemented in biology when you have E. coli or other bacterium swimming around. So here's an example model I wrote that you can port over to StarLogo. The challenge in StarLogo is it doesn't have patch variables other than color and height that can basically diffuse kind of like you can in NetLogo. But so I wrote a model only using agents so that in the same way that you do in StarLogo. So the idea is right now I have say 90 ants around here and some pheromones, and the pheromones are emerging from the center where maybe say a food source is. Now these will be in your model being laid by ants that already found food and are walking away, or it could be ants walking away from the nest, dropping a nest pheromone. Ideally, you'd use a nest pheromone and a food pheromone. So here we're just going to show how these ants are going to walk around and go up gradient. So I'll go ahead and set this up randomly, and then here comes the pheromone field, and we'll watch the ants detect that and move up field, and we're keeping track of the mean distance or the average distance from the food source, and we can turn on some labels here looking at how much of a gradient these guys are sensing. The code is going to look a little bit different than StarLogo, but I think some of the variables you'll have are going to be similar. You'll have maybe a speed of your ants, and these how often they're sensing the gradient versus walking, and that's maybe how often they make a choice to turn randomly or not. How long the pheromones live. So if you notice, if I turn that down, that pheromone gradient gets smaller in radius. And then we have something like the wiggle angle of the ants. So if it's very small, they tend to move straighter, and as we get up to 360, much more in a random motion. And the code is in NetLogo relatively short, but so I would expect it to be similarly in StarLogo, probably just a few blocks to express. This is the setup up here in StarLogo. It's probably you're going to ask each of your ants to look at the pheromones in radius and basically compare the last count of pheromones in radius to the current count, and if its memory of pheromones were greater than the current count, well then they're going to randomly move about a little bit more. They're going to turn more randomly. Otherwise, they won't turn, and in both cases they'll just move forward with some kind of speed. And here we show the pheromones aging over time and randomly moving around. So I can help you port that to StarLogo if you got some time. That's it. Give me an email if you have any questions.